Take a look. I have written some of the elements and their respective valencies. Don't forget what we explained, that valency is the combining power of an element. It can also be said to be the total number of electrons on the atomic shell of an atom. So if you understand clearly that every metal will lose electron, while non-metals will accept electrons. And if you know in chemistry that if an element loses electrons, it becomes positively charged. If an element, on the other hand, accepts electron, whether an electron or electrons, it becomes negatively charged. So metals are known in chemistry to donate electrons. So it is principally cations. If you understand what I mean, cations are positively charged ions. So metals are cations, while non-metals are anions. Anions being that they accept electrons. If you are using a mathematical idea and come into this thing, you have an issue. Remember, I said when elements lose electrons, they become positive. And when elements accept electrons, they become negative. Get it right. It is not mathematics. When you lose, it becomes minus. When you accept, it becomes plus. No. This is the opposite of that. When if you are an element and you lose this electron, automatically you are now positively charged. So if you are another element and you accept electrons, you have automatically become negative. That is what happens. So hydrogen have plus one, which means hydrogen can lose one electron. On the other hand, hydrogen can accept one electron. That is the simple meaning of this. Sodium is plus one. But let me just give an illustration how this thing come into play based on my second definition of valence. So if you watch sodium now, sodium atomic number of sodium is what? 11. And if you know electronic configuration very well, it is 281, which means the K shell will take two electrons, L and M. Which one is the outermost shell? The outermost shell is M shell. The last shell, how many electrons are you seeing there? One. And because of the fact that sodium will really lose this one, that is why the valency has become plus one. Sometimes you misunderstand you always misunderstand valency and the oxidation number. Normally, valency has no charge, but oxidation number will have charge. But I am putting it this way so as to use one thing and explain other ones. So calcium is 20. If you watch it now, 2882. If you add all these things, it will give you 11. If you add all these things, it will give you 20. That is electronic configuration using KLOL or in the main shell. This is the K shell. This is L M1 to what N. If you don't understand, maybe we do a separate video on electronic configuration. But I know I have done electronic configuration in the sub shell. That is SPDF notation. So if you check down in my channel, you'll see it. Which means the outermost shell of calcium is how many electrons you are seeing there? You are seeing two electrons. That is to say that calcium can really lose these two freely. That is why the valency is what? Plus 2. Let me quickly go to chlorine. Chlorine, the atomic number of chlorine is 17. So which means the electronic configuration is a 287. So somebody may tell me that, okay, the balance should be plus 7 because it will lose this 7 really. If you watch very carefully, instead of chlorine to lose 7 electrons, which is the outermost shell, it will accept one to make it complete. And don't forget that we have two stable electronic structures in chemistry. We have the one we call duplex structure. Okay, duplet or octet structure. Duplex structure is when element becomes stable at 2, octet when they become stable at 8 electrons. This is 8 electrons. So now it is evident that, in fact, what happens when we have chemical reactions? Atoms are struggling to reach bond stability. That's what is happening. They are struggling to reach bond stability. What do we mean by bond stability? Whether to be stable at duplet or stable at octet. Octet means that the total number of electrons on the outermost shell will be 8. So if you watch very carefully, chlorine will be struggling to make this one to be 8. So instead of chlorine to lose this 7, it will accept 1. And remember what I said earlier, if you accept electron, you have to automatically become negative. So that is why the valency of chlorine is -1. Why? Because chlorine will accept 1 electron to become chlorine ion. That is why that 1, accepting 1 means that this one will now be 8. That is why it is -1. The same way with oxygen. Oxygen is 8, it is 2 and what? 6. If you add this thing, now this is K shell, this is L shell, it will give you 8. Can oxygen lose 6 electrons readily? The answer is no. Instead, it will accept 2 electrons to be stable at a octet structure. So that is why oxygen accepting 2 electrons, if you remember, when you accept, become negative. That is why the valency of oxygen is -2. Whether valency or oxidation number, the important thing is for you to understand the point. It's -2. Remember why we are struggling to learn all these things. We want in a situation whereby we can write comfortably the structure or the formula of compounds. Very, very, very easy. So that is it. We are going over to radical.